Then let's go to the session 1, social impact of AI. Artificial intelligence has a growing impact on human beings and society. In this session, 3 invited senior scholars from the machine learning, natural language processing, and the field of law to share their views, the insights on the fairness, ethics, and the robustness of AI, and how we should be ready for these challenges. Firstly, I would like to welcome Professor Fung from the Hong Kong University of Science and Technology. She is the director of the Center of AI Research, which is an interdisciplinary research center on top of all 4 schools at the Hong Kong University of Science and Technology. She is also the fellow of the AAAI, ACL, and the IEEE. Her research interest lies in the building intelligent systems that can understand and empathize with humans. Today, her speech is towards human valuebased NLP. Professor Fung, please.
Thank you. Can you hear me?
Yes, it's very clear.
So I'm going to share. So the topic is value-based NLP. So before I go into some of the technical stuff, I want to share some of these, clarify some of these terms that we hear all the time, namely beneficial AI, ethics in AI, ethical AI. I think, following the excellent keynote earlier, I don't think I need to explain too much, and everybody here is an expert. I guess I want to point out that ethics in AI are actually various moral philosophical principles that are pertinent to AI, whereas ethical AI technologies that are designed to adhere to ethical principles beyond just legal requirements. So another way of describing ethical AI is human value aligned AI. One example is the IEEE ethically aligned design as a document, which is comes out from a study of different moral philosophy approaches and principles. It is a translation of different ethical principles from two approaches in intelligent system design. And responsible AI. So in the past year, I was actually consulting Meta on the topic of responsible AI. And I find a great similarity between the Microsoft's principles and the Meta's principles. I think we're all looking at the same dimensions of responsible AI. So, namely AI models and systems that are transparent, explainable, gives user agency and control. It's robust and safe, and it's fair and inclusive. Also preserve privacy and security. However, I want to point out there are 2 sides of responsible AI. We have been talking about making AI systems themselves responsible, but there are also other work that are using AI to safeguard human online behavior and interactions to align with ethical values and legal requirements, such as fake news detection, harmful interactions, illegal online behavior, so on. And so that's also another kind of another way of using AI to make the society more responsible for our behavior. Why do we want to do responsible AI? Sometimes I'm asked this question. Well, the short answer is that we don't have any choice. Currently, major countries and jurisdictions have already established guidelines and regulations for ethical and responsible AI. Various academic professional societies have ethical committees and reviewing guidelines for our research paper submissions. Public concern over the impact of AI companies has led to over 100 published guidelines and policies since 2017. Professional societies such as ISO and IEEE are establishing various industry standards for AI governance. And we also all belong to different professional societies, and they have codes of conduct that mandate that we build technologies that do no harm. So, in addition, guidelines of AI governance often translate into legal requirements down the line. And users today are increasingly skeptical about AI systems that are not safe or biased. Interpreting and operationalizing responsible AI standards and guidelines have nevertheless met with steep technical and structural challenges. But I would like to emphasize, like we have seen from the keynote just now, that this societal challenges presents itself an opportunity for AI as a field to have new research directions, approaches, and measures. In time, all AI should be responsible AI. Now, there's a question of who is responsible for responsible AI. So there are multi-stakeholders in this whole ecosystem, ranging from regulators to all the way to standard bodies, to users, developers, and researchers and ethicists. And here, since we're researchers, and I want to point out that we actually publish a lot of data sets and codes and research results, and we talk to the media as well. So we actually have a huge impact on how AI is done and how the society perceives AI. We also advise regulators and policymakers. And we need to, however, we are, as researchers, are not really regulated by anybody. So we have a huge responsibility as this, the upstream from this eco chain of AI research development to usage. We have a huge responsibility ourselves to do our AI research and development. Now, the core challenge of value-aligned NLP or an AI is twofold, which is, first is, what are these values? What are these human values and who defines them? Second is, how can AI or NLP algorithms and models be made to align with these values? For example, in classification, in generation. So what are the desirable human values and who defines them? So many organizations, the governments have published lists of desirable ethical principles and standards, and so on. Nevertheless, we should anticipate value definitions are dynamic and multidisciplinary. And therefore, we need to modularize the set of value definitions external to the development of NLP algorithms. Meaning, other than high-level values such as transparency or explainability and so on, there are many value definitions that should not be hard baked into our algorithms. And even less engineers and researchers who are AI builders and algorithm designers should not be the ones who decide what kind of values we need to put into our systems. We need to work with ethicists, philosophers, and other humanists, and representatives of our society. We need to work with them together. And so I want to show some kind of example today, how we might be able to do that. First, I want to point out that human values are culturally dependent and dynamic. Take the value of non-discriminatory or sexism, anti-sexism. A statement such as women should be protected by men is considered sexist if the value is non-discriminatory. But in some cultures, the value could value, some societies value chivalry above other values. And then such a statement would be considered harmless or non-sexist. Human values are also multi-perspective. Take the classic example of this trolley problem. If you ask this ethical dilemma question or ethical quandary question, whether one should prevent killing 4 people or 5 people on the track by killing 1 person on the other track using a trolley. So that when ethicists try to answer this question, they answer it from different moral philosophical approaches. Human values are describing natural language today. This is why NLP plays a role in this human value alignment. These values and regulations and guidelines are often described in natural language, such as these are examples from the Chinese AI ethical principles and the EU AI key requirements, two such guidelines. And you can see a lot of overlap between the two. Human values are also multidimensional. Take the example of sexism. There are different categories, subcategories of sexism, ranging from role stereotyping, attribute stereotyping, to body shaming, and all the way to hostile work environment, denial or trivialization of sexist misconduct and threats. So there are different dimensions in one value. The keynote brought up the issue of large portraying language models. And there's a lot of discussions today as to how we can use these models, often seen as foundational models to many NLP systems and also visual and language systems today. So these foundational models are very, very powerful. We have already heard earlier. But thus far, they are uncontrollable, not transparent, and unstable if we use them as they are. Scaling makes them more powerful, but they also remain unsafe. Therefore, it makes it undesirable to use these models for classification or generation tasks in NLP without heavy pre-processing, fine-tuning, or post-editing. For example, there is no commercial use of generative conversational AI systems that are using these models. And there are also catastrophic output from neural machine translation systems when they use foundational models. So models are powerful, but they can also lead to very unsafe output. So how do we align these language foundational models with human values? Should we pre-process data to filter out harmful content, but manipulating training data might disable some downstream use? Should we debias and detoxify the models and the embeddings? Well, these foundational models and embeddings encode the DNA of human society and culture. Manipulation of the model space might render them brittle. Should we attempt control generation? Now, even without fine-tuning, control generation works for some attributes, such as positive sentiment, no swear words, but not values such as sexism and racism, because they are not lexicalized and they can be multi-category. And the control generation can be computationally expensive. What about post-processing the output? This is what we do all the time now. All systems have post-processing if we want to ensure safe output. But what is the principal way to design a good post-processor? And currently, there are different approaches to align NLP systems with defined values. For example, a work from OpenAI proposed to fine-tune these foundational language models to adapt to a manually crafted values-targeted data set in order to yield a value-targeted model. And then they with a human in the loop, they iteratively fine-tune, fine-tune this data set and then fine-tune the model iteratively. This is obviously an expensive process. And another paper that trained a system called Delphine. It is a Q&A, ethical Q&A classification system. So you can ask whether some statement is ethical or not to this system, which was trained from a common sense norm bank that contains 1.7 million examples of people's ethical judgments. However, there's such a classifier has this risk of catering towards the average, statistically average moral judgments from this 1.7 million examples. And then when you go to another culture or another context, now you have to collect different examples. So today I want to show some toy experiments or initial experiments we have done in externalizing value definition and in value alignment, what we call a value-based NLP, where we actually decouple value definition. What we want to do is externalize value definition. We want to input value definition as instruction, okay, at the command level to any NLP task. So I want to show an example of classifier and example of a generation system. Here is an example of a ethicist system, what we call AI Socrates. Again, use the example of trolley problem. We want to have a Q&A system where if you ask a question, should we kill one person to save five people in danger of being hit by the trolley? Instead of giving you a definite answer or factual answer, just like classical QA systems, this is a system that will answer this question with reasoning, with different perspective. And you can give this system the particular moral philosophical approach that you want, or the system will attempt to answer from different ethical perspectives. So I will skip this. And so this is the first step. When the system is given a ethical quandary question, it will look for appropriate relevant ethical principles from a pool of existing moral philosophical principles and collected human rules of thumbs. Once it's found, so we train a classifier to retrieve the relevant principles. Once it's found these principles, we use a prompt-based few-shot learning to prompt the large language models for a principle-guided answer. So to show the examples, so here, this is the first step. Given the question, human can select two perspectives, one in blue, one in brown. And our automatic selection will we also select these two perspectives, two principles, one in blue and one in brown. And you can see that it has selected two different moral philosophical approaches and principles. And then the second step, once it's retrieved these principles, we'll go into the large foundational language models using prompt-based few-shot learning and come out with principle-guided answer. So here are human principles generating automatic answers. I will give you a second to look at the answers because I'm not going to read it. So it is answering this question from two different moral philosophical perspectives. Another example is automatic principles and retrieved and generating automatic answers. Okay, as you can see, it is answering from two different perspectives. However, the coherence is not perfect yet. Then we use the New York Times ethics column data set to do human evaluation. So we compare the human answer to our system answer, and we ask human judges to evaluate from multi-perspectiveness, from coherence, and just and reasoning ability. And the system is found to have the ability to provide multiple perspectives and to be able to provide justifications on these perspectives. At the coherence level, it is not as coherent as human ethicists yet. So there's the step that needs to be improved. Now, next, I want to talk about this. The second step of this system is still using prompt-based few-shot learning. So the answer still needs to be post-processed because some of the answers are not really desirable. Now, the next example I want to show. So these are the issues, right? Some of these answers can be still risky. So yet we found a way to encapsulate the language models and the embeddings as they are. So what we want to do next is do not use them directly in zero-shot or even few-shot learning, but we want to use these foundational models and use few-shot learning to prompt synthetic training data. Once we prompt this synthetic training data, we use that training data to fine-tune a more controllable, smaller model down the line, right? So that's the proposal we have. So these are the experiments on using human value aligned classification in this way. So again, I'm using the example of sexism classification. So in the traditional way, you might give these values, might give a few examples of sexism examples to the large language models, and then you can use few-shot learning and train the classifier like that. Now here, we actually want to train a classifier that takes additional input, these natural language-based values. So we will have value with question and answers. And then we use these to prompt training data from the large language model. And then we use them to fine-tune a value-aligned model down the line, okay? What do I mean by that? Let's go. So these are the examples again of different categories of sexism. So we come up with this natural language description of each sexism values, also its counter values. And then we use that to prompt examples from the, we use that to prompt the examples, training examples from the foundational models. And then once we have a set of these training data, we use that to fine-tune a smaller model, a value-aligned model, such as, so the foundational models could be OPT, GPT-3, and so on. And the smaller model we can fine-tune could be BARD or Beta, and so on. So here again, these are the training examples. We'll give these examples to the foundational model, and we come out with more examples, synthetic training data. So here, this classifier, instead of probability of output given input as a classifier, we actually added V. So it's a probability, we'll try to maximize probability of output given value and the content and the model. So in this case, to do so why don't we retrain the language model with the additional variable? Because that would be expensive, and we also don't want to retrain the language model. Actually, in a lot of research groups, we're not able to retrain these foundational language models. So we want to do this in the smaller model, to a smaller model. So we just retrain this classifier with the additional value, and then this is how, and then you can give the value at runtime, at inference time, as instructions. All right, so this is, how is my time now? Let me know how much time I have left.
You have 5 minutes and maybe 7 minutes.
Okay, so then I can talk a little bit more about this another issue of controlling hallucinations. So one of the biggest challenge in using foundational language model is that whereas they give us very natural and human-like generated content, they also can hallucinate things that are not there, meaning summarizers would output things that are not in the original content. It will introduce bias, it will introduce toxicity, it will introduce catastrophic output in machine translation systems, in conversational AI systems, right? So, and these hallucinations there can be two kinds, intrinsic or extrinsic. And intrinsic hallucinations can be verified, but extrinsic hallucinations cannot really be verified from the source content. So here's an example of such a generation, right? So if we prompt the language model with one truthful prompt, one of lung cancer symptoms is shortness of breath, and then one actually erroneous prompt, cancer can be prevented by drinking too much alcohol, the language model will not know which one is correct and wrong, and it will continue to generate more content, more text. Now, so one way of so here's more examples of hallucination from vision language models, and they are usually inherited from the textual language models. It basically sees things that are not there. For example, seeing text message from a picture of a smartphone, seeing a parking lot from picture of diner food, seeing a mirror from picture of a chest, and seeing a sink from a picture of white refrigerator. So it's just seeing things that's not there. Now, contributions to hallucination are many. They come from the data, they come from training and inference. And so they can be data bias, or it can be exposure bias in the model, imperfect representation, erroneous decoding, or parametric knowledge bias. And these are some of the common mitigation methods. I won't go into detail, but I want to point out that in conversational AI, we often control the generation from using foundational models. So one of the problems of these foundational models is that we are using beam search. Okay, when we use neural conversational AI systems, we are using generation-based models, and generation-based models would tend to generate repetitive and boring answers because it would maximize the likelihood. So one way of diversifying such answers is to use a method called nuclear sampling, which is randomize or restart the generation from time to time to give it more surprising answers. This is actually how humans converse. You know, when we talk to each other, we tend to generate more surprising answers, right? Than just to maximize likelihood. But this nuclear sampling strategy introduces a lot more risk of hallucination in conversational AI. For example, this is a generated answer of Harry Potter was written by a Nigerian in 2001. So there's generated extrinsic hallucination. So to mitigate this, one way we have adopted is to, instead of saying you can use nuclear sampling for each of the word that's being generated, we control the level of diversity, or control the level of randomness as we go down the sentence length. So this is called factual nuclear sampling. Again, going forward, I want to show you the example. So here, green are the factual answers, and the red are the erroneous answers. So if we use greedy approach, following this prompt, one of lung cancer symptoms is shortness of breath. If we use greedy approach, it generates correct output, but it's repetitive. It generates the same output 3 times. If we use nuclear sampling, it's not repetitive, but it generates some erroneous answers, right? The wrong non-factual answers in red. Now, if we use factual nuclear sampling, then it generates non-repetitive and mostly correct answers. Again, following the wrong prompt, the non-factual prompt, then greedy approach continues to generate non-factual prompt, nuclear sampling as well. But if we use factual nuclear sampling, then it goes back to language model and looks for more factual output. Remember that in the foundational models, there's more factual on the factual content in the foundational models, non-factual content. So factual nuclear sampling allows us to go back to the foundational model's inherent content more than random. So there are some future directions. I will not go into the details of future hallucination control methods. I want to conclude by the following. In order to have human value-based NLP, we need to work on responsible AI that entails new measures, new metrics, and new approaches of classical NLP tasks. So, for example, QA, I've shown one example of Q&A system in NLP that does not just generate one answer or one factual answer. It needs to generate different answers depending on different input values. And it needs to provide justifications to its answers. Human values are dynamic, cultural, contextual, multidimensional, and multi-perspective. We need to decouple value definition from value alignment engineering in order to collaborate better with ethicists and policymakers. We need to provide value definition as dynamic instructions to NLP systems for transparency and explainability. Large language models are powerful, but so far uncontrollable and unstable. Nevertheless, we need to preserve these language models, their integrity, while mitigating the risks in downstream NLP tasks. So this is what I have to talk about today, and I would like to open this for Q&A. Thank you.
Thank you very much. Thank you very much for this great speech, Professor Fung. We learned a lot of the human value-based NLP. And here comes the Q&A session. Oh, I see someone is raised your hand. Please open your microphone and ask Xiaoyuan. Yeah. Go ahead.
Okay, Professor Fung. Thank you very much for your very impressive talk. And actually, I'm also working on very similar topics. And I think I have two questions. The first one is that I think your value-aligned NLP or your value-aligned method is very interesting. And I want to know, it seems that you use some retrieval instance or sentences as the default definition of the values. So I want to know, maybe such a kind of definition is quite high level or cross-grained. Maybe you cannot get enough fine-grained information from this natural language definition. So do you think they can provide enough signals to control the model? Or how do you think another kind of control method, like we use some rule-based method or some more detailed rules to control the model? How do you think these two kinds of methods?
Yeah. Very good question. Obviously I don't have a definitive answer. These are all initial experiments. So I actually agree that this kind of value aligned NLP is like combining generative models or like neural models with, it looks more and more like a rule-based system, because we actually give it moral or ethical rules, right? Yeah. So it's an attempt at doing that. And you're right, there are very different grain, cross-grain and fine-grain value definitions out there. When we did our experiments, we just collect as many as we can find. There are very high-level value definitions by different moral philosophers, so like deontological or utilitarian. Those are very high-level moral philosophical ethical principles. And then you have like very fine-grained rule of thumbs. We actually use everything. And what's interesting is that when we prompt the pre-trained language models, you can be pretty sure that those language models have already seen all of them or most of them, at least in that language, okay? Because, people have written about ethical principles in all kinds of texts. So those language models, if they're big enough, they have seen them. So that's what's very interesting. But yes, we need to do more work in order to be able to do a more controllable generation or classification, kind of a rule-based yet neural approach.
Oh, okay. Thank you so much. So I have another question. Is that you just mentioned you use this retrieval instance to do something like knowledge distillation, because we don't want to fine-tune the large or the big model. Yeah, but this may cause several problems. The first one is that to my knowledge, I think knowledge distillation in some cases may also amplify some social bias. I'm not sure whether you read some relevant papers. And how can you ensure that this distilled model can avoid or cannot amplify this social bias? And the second problem is that, have you considered something like the forgetting problem? Because you use this instance to do the disentangled or do something like the fine-tuning. And I think this method may influence or may have some negative influence on the model's capacity on downstream tasks.
So to answer the first question, in our distillation experiments, we actually give it specific value examples. So, you need to, I give you pairs of content, value, output. And then we ask the model to generate content value output. So you actually can look at it. So it becomes explainable, right? If it's biased, you will see the value there that's being biased. So, so the data you use for training is actually self-explanatory. Okay, so this is what, you can actually see it. So that's the important thing. So also when you input to a classifier or whatever, I'm asking you to input those values explicitly at instruction level. So when you build such a system, you can actually trace back to where the value came from, right? So it makes it explicit. So it's just, that's what I mean by externalizing the value definition. You can see it. Yeah. The second question was, I forgot the second question. Forget from this.
Yeah.
I already forgot.
That's the forgetting.
Yeah, we have not really measured that. So there's more work to be done. So these are really initial experiments.
Okay.
Yeah.
Okay. Thank you so much.
Yeah.
Okay.
Thank you for your question.
For the time limit, we have to stop the Q&A session here. And thank you for the great question and discussion here.